section 15.2, which is about defining our trig functions. And more importantly, we're going to understand what reference triangles are, because we're going to use those a lot. So what are reference triangles? Well, first of all, as we've talked about before, we could have a ray in any one of these four quadrants. And if we were to draw a line segment from the tip of the ray down to the x-axis, you would end up creating a right triangle, actually. What you need to understand is for your reference triangles, we are never ever going to use the y-axis. It's always going to be with the x-axis. So for example, in this triangle here, we would draw it down to the x-axis. Over here, we would draw it down to the x-axis. This one goes down to the x, and this one goes down to the x. So you can see all of these little right triangles that we get. These are going to be your reference triangles that we're going to use when we try to find the sine and cosine and tangent of specific angles. So what is a reference triangle? Well, ignore the one in the first quadrant because that one's pretty standard. But when we get to these other three, say we were trying to figure out the cosine of 120 degrees. Well, that's this angle right here. That angle is obtuse, so we wouldn't have a right triangle that would go with it to be able to use our trig definitions of sine, cosine, and tangent. So what happens is we take this other angle that is created, basically the supplement to it, right here, and then using this right triangle, we can figure out the sine or cosine or tangent of this little angle right in there, this angle right there. And it actually, quite interestingly enough, turns out to be the same as if you were trying to find the sine, cosine, or tangent of the bigger angle over here. That's why I call it a reference angle, because you reference this angle to figure out the sine and cosine and tangent of the bigger angle. So all of these have that situation. So for over here, this big angle going all the way around like that, well, that's way more than 180 degrees. Can't even get a triangle out of that one. But if we use the little reference angle here that's created with the x-axis, it's the same. Okay, and you can imagine what that one would look like as well. So you'll get the hang of this after we do a ton of these, and it's really not that hard. But let's go back and redefine what sine and cosine and tangent are. So the sine of theta, the sine of your angle, you probably remember it as opposite over hypotenuse. But if we look at this, I'll just use this standard right triangle right here. Opposite, this is the y direction, and then this is the hypotenuse. So they say y over r, and I suppose I could put a little x and y. So this is x, this is y. Woo! Okay, and then this is r. Okay, so we can use that to reference. Cosine is adjacent over hypotenuse, or x over r. And then tangent is opposite over adjacent. Okay, so y over x. And so how do you figure out what r is? Well, r is just the Pythagorean theorem. So you would take x squared plus y squared equals r squared. So you could take the square root of that. Okay, so whether you want to use the x's and the y's and the r's, or if you still want to go with the opposite, adjacent, and hypotenuse, the SOHCAHTOA, then that's either way will be fine. Whatever works best for you. Okay, so let's do an example here. They're going to give you a point that your ray is going to pass through. They're going to ask you to sketch the reference triangle and then evaluate certain trig functions. So when we look at this point 6, -8, if we go over 6 in the positive direction and down 8 in the y direction, our point is going to be somewhere in here. Now, I do not need you guys to be graphing this on graph paper, so we don't need to be concerning ourselves that this is exactly 6 units, exactly 8 units. We're just going to sketch an angle that is going to be in the fourth quadrant. Okay, and I typically make it at a 45-degree angle just to give us the most space to look at. You can do whatever you want. If you want to be particular, go right ahead and use graph paper. Next thing we have to do is to make our reference triangle. So remember that we do not connect it with the y-axis, but we are going to connect it with the x-axis. So we're going to draw a line going up there. Now these coordinates right here, the x and y coordinates, are going to give you the length of this side of the triangle and the length of that side of the triangle. And notice that I kept the negative sign. This is the one difference in trig than in geometry. We're not considering this simply as a length of a segment, we're also talking about direction. Okay, so the negative is telling us the direction it's going, and the 8 is telling us the length. So you do want to remember your negative signs. So from the 6 and the 8, we should be able to figure out what r is, or the hypotenuse. And luckily, if you remember your triples, 6, 8, 10, there you go, pretty easy. Once we have this, remember they're asking us to find the sine and cosine and tangent of this angle that's created by this ray, like that, right? But we're using this, here's my, oh, that was a really bad theta, but we're using that angle right there to reference. That's our reference angle, and this is our whole reference triangle. So the sine of theta is negative 8 over 10, which is going to reduce to negative 4 over 5. The cosine of theta is going to be 6 over 10, which reduces to 3/5. And then the tangent is opposite over adjacent, so negative 8 over 6, so negative 4/3. Okay, so while theta is really technically this big angle here, we're using this little theta to reference in order to figure it out, and they are the exact same answers, which is kind of cool. Okay, next example. This time, they're telling us the cosine of theta is this ratio, negative √3 over 2. They're also telling us what quadrant we're in, and they need to tell us that. I'll explain why in a minute. And then they're going to ask you to evaluate something. So in this case, they tell us that our ray is going to be in the third quadrant. So we're going to go ahead and draw that in. And then we're going to draw in our reference triangle up to the x-axis. And then what you have to remember is in cosine, this is the adjacent side, and this is the hypotenuse. Now with the negative, we have to figure out, does it go with the √3 or does it go with the 2? And the rule of thumb is that your hypotenuse, or this ray, r, radius, whatever you want to call it, is always going to be positive. Okay, so the 2 that's going to go right here, that's the positive. That means the √3 has to be negative. So let's plug those in. Then you can use your Pythagorean theorem, or maybe you recognize the 2 and the √3 as being a part of a special triangle. It's part of the 30, 60, 90 triangle, right? So we know that this is going to be a -1. And that's the part right there that people, when they're calculating this length, they forget the negative, and then it messes up their answers, so be careful. Okay, so we are going to evaluate the sine and tangent of theta. And so remember that the actual angle that we're working with is this angle, but we're using the little reference triangle, right? So this is theta right there. But we're actually using this little angle here to figure it out. Do I need to draw that in? I can draw it in. This is the angle we're looking at. Okay, so there's sine. Sine is opposite over hypotenuse. And then tangent is opposite over adjacent. And the negatives cancel each other out. And then when you have 1 over √3, you've got to remember to rationalize that denominator. So it's going to be √3 over 3. Okay? So hopefully that won't be too difficult for you guys. Once you get the hang of drawing these little reference triangles, then it's a piece of cake. Okay, one other thing that I need to show you, and that is a nice little way to remember which quadrants your trig functions are positive in, because eventually, throughout the rest of the course, we're always going to be referencing the quadrants where sine is positive or cosine is positive, and by contrast, which ones they're negative in. So if we use this kind of memory device that all students take calculus, whether that's true or not, I don't know, but that's a way to remember which quadrants your trig functions are positive in. Using the first letter of each word tells you which trig function is positive in that quadrant. So the A, or actually the whole word all, means that all of your trig functions are always going to be positive in the first quadrant. Okay, so over here, this is the S for students. That means that sine is positive in the second quadrant. Down here, T is for tangent. So tangent is positive in the third quadrant. And then last but not least, the C, cosine is positive in the fourth quadrant. So what that means is if you were over here in the second quadrant, sine is positive there, but that also means that cosine and tangent are both negative here. Okay, same thing down here, tangent is positive in the third quadrant. That means sine and cosine are both negative there. Okay, so if you look at this, each trig function is positive in two quadrants and is negative in two quadrants. For example, they're all positive in the first quadrant and then positive in one other quadrant. So sine is positive in the first and second, tangent is positive in first and third, and cosine is positive in the first and fourth. So in that previous problem, when they told us that it was in quadrant 3, because cosine was negative, we needed to know, is it over here in the third quadrant, or it could have been potentially up here in the second quadrant, because cosine is also negative there. So that's why they are telling you what quadrant you're in. All right, so please remember this. All students take calculus. I'm going to reference it all the time throughout the rest of the year. So hopefully you'll know what I'm talking about when I say that, and I'm not just saying a silly phrase. Okay, that's it. Hopefully that wasn't too bad for you guys.